So here is an example for this Hebb Net model. I have taken an AND logic with both binary input and output pattern. Okay, so my input is going to be binary and output is also going to be binary, and I'm going to follow this Hebb's rule. I'll show you how this is actually calculated. Now the architecture of this Hebb's net is very simple. See, you have your bias value as x0, and for AND logic you have two inputs, x1 and x2. So x1, x2, and your output is going to be your y, and it is connected using the weight as W0, W1 and W2. So I have three weights as W0, W1 and W2, and this takes the input over here from the patterns and it is going to produce an output. So this is the architecture for AND logic when I take the input neurons as 2. Okay, and it is going to take the binary value, so my inputs are going to be 0 or 1. And you know the AND logic, right? 0, 0 is 0, 0, 1, 0, 1, 0, 1, 1, 1, 1. So this is my input pattern, and the x0 is for bias. Bias value is going to be always 1, so it is 1 for all. Now what I'm going to do, I'm going to follow a Hebb Net learning algorithm. So this is the steps for Hebb Net. First of all, I take initialize all the weights to 0. That is the first step. So all my weight vector of W0, 1, 2 is assigned as 0. So initially all my weights will be 0, and I'm going to take the first input pattern. So my first input pattern is this. Okay, so this is my S and this is my T. T is the target, S is your input. So I'm going to set your x0 value as 1, S value, that is x1 as 0 and x2 as 0, and I'm going to set the output y out equal to target. So the target value was 0. So automatically we set everything and we go for adjustment of weight. That is how your Hebb Net work. Okay, so there is no way of sending this input, find the output and check whether the actual output and target matches and all. There is no error calculation. Rather than an error calculation, we take a pattern, adjust the weight. Take the next pattern, adjust the weight, and we keep on adjusting for all the weight, all the input patterns, and finally we'll check for whether the net is able to recognize the model or not. Okay, so with this I'm going to proceed with all my x values are set and y value is set. Next step is I'm going to happen this. I'm just going to make this weight adjustment. So this is my del value. Okay, so I have separate column for filling this del value. That will be helpful for you to understand. So I'm just going to multiply my x with the output value. So output value is nothing but my target value. Okay, so the target is 0. So 0 into x0 will be your del naught. 0 into 1 is 0. And again for W1 is the adjustment between the weight between this x1 and y. Okay, so the weight value is 0 into the target. So this is also 0, and again 0 into x2 is also 0. So there is no weight adjustment happens in the first step. Okay, so here I have to multiply my x value along with the target value. Since my target value is 0, I don't have any weight to be adjusted over here. So it is going to be 0 for all. So what will be the new weight then? The old weight is 0 plus the adjustment to be made is also 0. 0 plus 0 is 0 for all. Okay, so this is how the Hebb Net work. Since the input that I have taken is the binary input and the logic I have taken is AND, it is 0 for all, most of the category. So till this, I don't have any weight adjustment to be made. Okay, I am going to repeat the same procedure again. Now I am going to set this x0 value as 1. x1 value as 0 and x2 value as 1. Okay, and the target remains 0 as it is for my second pattern I am discussing. So it is going to be 0 again. So the adjustment of weight is, I can write it, it is t into x0, t into x1, t into x2. So target value is 0. 0 multiplied by anything is going to be 0 for all. Okay. So for the second input pattern 2, I don't have any learning that happened over here. So my output is going to be 0 for all. The new value plus the old value. It is 0 plus 0 is going to be 0 for all. So this happens for my third pattern. So this patterns I can have it as this is my first, second, third and fourth. For my third pattern, again I am going to have the same procedure. This is my target and this is my x0, x1, x2. And how my adjustment, weight adjustment is happening? It is target into x0, target into x1, target into x2. Again, it is 0 multiplied by 1, 1, 0 is going to be 0, 0, 0. And the old weight plus new weight is going to be again 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 0 is 0. Okay, so for AND logic, till this place you don't have any other weight adjustment happening. So I will show you another example with the bipolar input where from each and every step some weight adjustment happens. Okay, so the last value is, I have a target value as 1. Okay, so when I take this fourth pattern, my x1 is 1, x2 is, x0 is 1, x1 is 1 and x2 is 1 and your target is also 1. Okay, so when I said all this x0, x1 and x2, the weight adjustment formula is xi into y out. Y out is again, it is the target value. Okay, so directly I can multiply this target value into x0, which is 1 into 1 is 1 and x1 into x1, so t into x1, 1 into 1 and again t into x2, 1 into 1 is 1. Okay, so I have some updation in the weight in the last step. Got it? So finally with this, when I want to update the weight, old weight plus the new weight. So W0 old equal to, W0 new equal to the old weight 0 plus the updated weight is 1. The change in weight is 1. So 0 plus 1, 0 plus 1, 0 plus 1. Okay, so this is my final weight to be adjusted for my Hebb Net model. Okay, so this learning rule is, this is a training algorithm. So training algorithm is nothing but we are going to assign the weight vector. Okay, what a training algorithm will do now, it takes each and every training or input output pair, find a way to make the network to learn. Okay, so finally it is done. Right, the training process is done. Whenever you take a machine learning algorithm or any kind of supervised learning algorithm, you have a testing phase too. Okay, a training phase is to check whether all is to verify or update the weight vector, and once the network is updated with the last weight vector, the next one is testing phase. So testing phase is nothing but we take each and every input pattern, we send that to this network and check whether it is recognizing or not. Okay, so I will show you with it. So my input is going to be binary input output category, and here I am going to set the threshold value as when my y value is y is equal to either 0 or 1, or I can have it as 1 or 0. When the value that is calculated is greater or equal to 1, my output will be 1, or else it is going to be 0. Okay, so this is your threshold. When my or it is greater or equal to 0, that's the usual procedure. When the value is greater or equal to 0, my output is going to be 1 or 0 otherwise. Okay, so this is my what is the activation function for y. Okay, so y takes the value of input, find the summation of everything, and it produces the output. This is your testing phase. Okay, it produces the output, and once after the output is done, we are going to check whether it is recognizing properly or not. Okay, we'll take one input pattern as such. So first, my input pattern is x0 takes the value as 1, x1 as 0, and x2 as 0. Okay, so how it is calculated? How your y in is calculated? It is the summation of the input multiplied by the weight. So 1 into 1 plus 0 into 1 plus 0 into 1 equal to 1 plus 0 plus 0 is 1. Okay, so this is y in value. And what is y out? Y out is after setting this activation function, what it happens. So when the end result of this is greater than or equal to 0, your output will be 1. Got it? So this is my first input. When I take the first input pattern, I am getting the output as 1, but the target needed is 0. So this is not classified properly. Using Hebb's rule for binary input-output pattern, when I said this, my net is not recognizing it properly. I'll check for the remaining possible inputs too. My second input pattern is x0 takes the value of 1, 0, 1. And what will be your output here? Y for my second possibility is 1 into 1 is 1 plus 0 into 1 is 0 plus 1 into 1 is 1 equal to 2. Again my y out is, it is greater than 0, right? My output will be 1. Again here my target needed is 0. Why my output I got it is also is 1. Not recognizing properly. Coming to the third pattern. Third pattern is x0 is 1, x1 is 1, x2 is 0. Okay, so for my third pattern, y input is 1 into 1 plus 1 into 1 plus 0 into 1 is 0 equal to 2. Again my y out equal to 1. It is greater than 0. So my output is going to be 0, but my target value is, it is 1, my target is 0. This is also not recognizing properly. Okay. And finally coming to the last input pattern. Last input pattern is all ones. So here is also it is 1. So for the last input pattern I am calculating y in, that is equal to 1 into 1 plus 1 into 1 plus 1 into 1, that is equal to 3, and your output is 1. Since it is greater than, the value that I have calculated is greater than or equal to 0, hence my output is 1. Okay, and the target needed is also 1. So this is the only pattern your Hebb's net is actually able to recognize. Remaining all the phases it is not able to recognize clearly. Okay, so Hebb's net is the basic learning model, and it is able to learn automatically, but it is not preferable for all possible inputs and outputs. So next example, like here I have shown you with the binary input and output. Next example I will show you with the binary input, and what if I have a target as a bipolar output, like targets between -1 and 1. Okay, when I say the target as a bipolar output, I will show you how the learning happens. Okay, thank you.